Hello and welcome everyone. My name is Mark Henry. I'm a senior engineer with Opmantek's North American office located in Charlotte, North Carolina. Today we're going to be talking about advanced NMIS setup and configuration. Before we get started, a few little light housekeeping tips. For those of you joining the GoToWebinar today, we will be following up the webinar with a link, an email with a link to the recording so you can view it. Feel free to submit your questions anytime, depending on which GoToWebinar client you have, which operating system you have. You may be submitting questions either through the chat window or the questions panel in your GoToWebinar control. When you exit the GoToWebinar, or if you quit earlier, if you go to the end, you'll be presented with a short 3-question survey. Please take a moment and fill that out. Also, for those of you joining us today live, if you'll check the GoToWebinar handouts panel, you'll see a PDF copy of today's seminar is attached there for you to download and follow along. Of course, if you're following this on YouTube or on the opmantek.com website, please come to the opmantek.com/learn portal. And from there, you'll be able to find a recording of this video along with the PDF and any accompanying handouts or documentation. So today, we're really going to be building on the basic NMIS setup and configuration webinar. I strongly recommend that you complete that webinar first before you move on to today's topics. It'll help put everything into perspective. It'll also make sure that your implementation of NMIS is properly installed and configured from a starting point. And it will also give you some basic background on navigating throughout NMIS so that you're much more familiar with the different menus and options that we're going to talk about today. In all, we're going to go through several different pieces. We're going to talk about interface collection policies and how those policies determine when and which interfaces are collected. We're going to talk about how to adjust individual node configurations for interface speed and node background information. We're going to talk about polling policies in NMIS and how you can adjust the default policy and create new policies for yourself. We're going to talk about how to create custom metadata tags, whether you call them tables or fields or metadata tags. The whole idea is to have additional containers for information. We're going to talk about managing event creation and thresholding. And finally, we're going to talk about how to import and export devices in bulk from NMIS. I always like to marry these webinars back to Gartner's IT Service Management Maturity Model. When you start talking about implementing NMIS, especially at the advanced level, you're really helping to move your organization well out of the level 0 or level 1 area and very, very strongly into level 2. And you're starting to fulfill requirements for level 3, and you're touching on level 4 of the IT Service Management Maturity Model. And this is really an important thing to understand, because the higher up you can move your IT department through this maturity model, the higher up you go. Not only are you increasing your own performance, but you're increasing the value, the overall value of the services you provide to your organization. Today, we will be talking only about Opmantek's NMIS performance and fault monitoring platform. Again, there's a prerequisite webinar I really recommend that you go through first. Of course, you have access to all the NMIS release notes, the downloads themselves, our online wiki, which has all of our documentation for NMIS. If you do not have a support maintenance contract with Opmantek for NMIS, feel free to reach out to our support team through the community questions board. If you're interested in talking about a support and maintenance contract, you can reach out to the US sales office, which is at usa@opmantek.com. If you're outside of North America, our US team will be happy to do an introduction to whichever account executives cover your region. We are also actively taking on beta users, beta testers, for the next version of NMIS, which will be version 9, which we're currently beta testing. So if you're interested in beta testing NMIS, reach out to us at beta@opmantek.com. We'll be happy to hook you up with the downloads and the relevant information. All right, without further ado, Let's start with interface collection policies. Throughout today's webinar, we will be toggling back and forth between PowerPoint and NMIS, a live demo that we have here as well. So we'll be stepping back and forth between the live product and a static presentation. So why are interface collection policies important? Really, it comes down to managing the total number of interfaces that you collect. Helps control the load on your polling server and on the device itself. The more interfaces you're collecting, the longer it takes, the more the device is having to prioritize between the SNMP gets and the SNMP walk and fulfilling the requirements that are coming at it from actually fulfilling whatever role it is, whether server, router, switch, etc. The more interfaces you collect on, of course, it increases the amount of time for an NMIS collect or update cycle. And it's important to understand that for each interface you collect, if you have the default storage policy in place, an individual interface takes about 3 megabytes of storage. So if you're looking at a router or a switch, and you might have hundreds or even thousands of interfaces on that device. Again, if each interface takes up 3 megabytes of storage and you're collecting on interfaces that maybe don't have traffic on it you care about, or don't have data you're ever going to look at, or isn't a useful interface, maybe it's a loopback, it's a service interface, etc., then why use up that storage capability? And of course, just from a kind of a DevOps and engineering standpoint, you should only collect performance data that is useful, right? And that's why we have these collection policies in place. So how do they work? There are 3 levels of interface collection policies in NMIS, and it starts with the NMIS device model. So for example, if your device is using the Cisco router model, inside that model are a set of rules that tell NMIS which interfaces to collect on and which interfaces never to collect on. So it's a both positive and a negative set of rules. The positive set always overrules the negative set at the device model level. Beyond the device model, there is a global set of policies in NMIS that's available in the config.nmis file. Those global policies overrule the device model. So if the device model says don't collect, and then in the global policy you say do collect, then the global policy will override the device model. And then finally, at the bottom level of tests are the individual overrides, which are a per interface basis. You can actually go into a device's configuration and you can say, for this one interface, I want to overrule the device model and the global policy, and I want to collect on this one interface. And there are several options that are there. We'll talk about all of those pieces. Let's take a quick look at what some of this looks like. On the left-hand side of the screen, we have an example, a small piece cut out from a device model. You can see here that we're starting a section called the no collect. So there's a collect section and then there's a no collect section. The collect section here is saying if operator status is null, so if there's no acceptable value in there, don't collect. If the if description includes the words sublayer or null or controller, so the vertical pipe is the or symbol, then don't collect. If the description starts with a hashtag, $, then don't collect. And then no description. If no description is true and the description is blank, then don't collect. If there is a description and no description is false, then it'll collect. If type. So if the type of interface is, again, contains the words other or software loopback or prop virtual or slip. So it's really looking for a real interface, a physical interface. So again, just an example of what you might find in a model. So again, the model is the first layer of control for looking at something. Over on the right-hand side, we have the NMIS kind of global settings. So these are the globals. They're in the NMIS configuration, which again is in config.nmis. There's a whole series of both collect and no collect options that are in here. You'll also see that there are some global events, some global thresholds as well. There's a lot of different global options here that override the settings that are in the individual models for the different types of devices. So making a change at the global level, again, overrides the model. So let's take a quick look at what that looks like. So at the top, we have an example of just an output of a series of interfaces, and you can see that that horizontal row that's in gray, collect is marked as false. So in opening the interface details for that device, and you do that just by clicking on the name of the interface in the far left column, you'll see that it says not collecting, no description, if alias. And so if we just simply looking at that piece here, you'll see, for example, there is no description. And we can actually go to node configuration for that device, and we can scroll down to that interface, and we could either apply a description here, or we could tell the system to go ahead and collect. So we could override at that individual device level. So again, your interface collection rules start at the model level. They then can be overridden at the global policy level, or they can be overridden at the individual device interface level. So there's several different levels that you can do this at. Let's switch over to NMIS and take a quick look at what that looks like. And I'm just going to close out a couple of my standard windows here. And let's go find a device. So here's Midgard. So Midgard is running the Catalyst iOS operating system. It's a 3750. And if I look at the interfaces menu option, so if I look at the interfaces menu option, that'll give me a list of every interface on this device, irregardless of the status. So rows that are in gray are not being collected. If you remember the example that we just looked at, you'll notice, and you might recall, for example, that this is the interface 1/0/9 that is marked false. And so clicking on the title of that interface gives us this panel. So this is the interface details panel, and you can see that collect is false. And again, the reason not collecting, no description, if alias. So if I go back to the interfaces again, and if I select, here's one that's being collected, and you can see the slight difference here. We have much more information in this left-hand column. So you have the availability, you have the physical address. It's collecting because it's following the collection policies. It could also tell you it was collecting because it had been overridden. And then, of course, we actually have historical data here as well. And, of course, we can drill into any of these interface items by clicking on the chart itself. And, of course, zoom in and out by clicking on the various regions of the chart. All right, back to our PowerPoint. So node configuration. We talked about the concept that you can override individual interface collections. It starts at the model level. You can override it globally, again, for everything on the server at the globals level. And then you can also do it at the device details level. So let's take a look at what that looks like. And again, let's go back to NMIS, and I'm going to open Midgard back up. And so we have Midgard here. And if you look at the top menu, you'll see there's an option here for node configuration. So if I click node configuration, I'm just going to move the Midgard panel over, bring node configuration to here. So at the top of this panel, we have options for changing the node configuration for basic node data. So we can change the contact, the location, the node type. Below the node area, then you start with a repeating pattern for the interfaces themselves. And these can be, I don't want to say complex, but there's several options that are here. So for example, the device is telling us on this first interface that the interface description is Eris second interface. It has no display name, so we're just going to use the Eris second interface, the description, as the display name that we'll use. But you can overwrite that. So anything you put in the replace by column, when you hit store and update node, it'll make that change for you. You can change the speed. Now, SNMP doesn't differentiate on an interface's in and out speed. It just reports one interface for that. But what we can do is we can actually override the speed of the interface at NMIS. Keep in mind the changes you make here to the node configuration are not, let me say it again, are not being pushed back to the actual device. So changing the contact or the location here and saying store and update does not change those fields on the device. It only changes the fields in NMIS. It actually marks those fields as being manually edited and then stores the setting that you give it. So if you need to change the speed in and speed out, you can either update that on the device, and then at the next NMIS update cycle, NMIS will pull that change in, or you can override that here if for whatever reason you can't actually make the change at the device. So you can make the change here if you need to. Oftentimes, that's an important consideration for dealing with something like speed. So keeping in mind the idea that you might have a circuit that's good for 10/100, and so it reports back as 100 megabits. You might have one that's 1 gigabit or 10 gigabit capable, and it's reporting that speed back. But in reality, you may be leasing a much smaller circuit heading through that. And so what you want to do is you want to adjust the speed on that interface to match the maximum that you're going to have moving through that circuit. And the reason that you want to do that and you want to override that kind of basic carte blanche information is because NMIS is going to produce an awful lot of graphs and charts based on a percentage of utilization. And so if it believes that the interface is a 1 gigabit interface, but you're really limiting the traffic through it to 500 megs, then you're always going to have your percentages are always going to be off. You'll notice here that there are other settings that you can adjust. So there's the ability to do speed limiting. So there's strict, and there's also off speed limiting. You can change your collections, and again, you'll see here that collect is set to true. So if it were set to false, you could actually force change it to true. And then there's, will this, do you want to generate events from this interface? And do you want to use thresholding? So lots of different options that you can use here. You can get very, very granular with NMIS. All of these changes that you do actually write out to a just a little hash file that's in a subfolder of the conf directory. And so you could make a change to one of these and see what that file format is. And then you could use a script to actually generate those files if you wanted to make a scripted change or widespread scripted change to your systems. All right, let's go back over to the PowerPoint again. Next on our list today is our NMIS polling policies. So the concept behind polling policies, rather recently, we had, it was a one-size-fit-all for the server. You had set a polling policy up for the entire server, 5 minutes, 4 minutes, 3 minutes, 10 minutes, 15 minutes, and that was how often every single device, regardless of type, was to be polled on that server. And so all devices shared that thing. But really what we came to realize was the concept that not every kind of type of device, class of device, group of devices needed to be collected that often. We would often run into businesses where the clients would say, you know, we use SaaS solutions for all of our really important stuff. We can't monitor those servers. We have a couple servers in-house, but we really only need to monitor them every 30 minutes. And so I only want to poll those, on a much slower scale. And would also have clients come to us and say, I've got some core routers, and I can't wait 5 minutes to poll them for performance data. I need to poll my core routers, every minute, every 90 seconds, every 2 minutes. I need to do it at a much faster rate and tempo than I do everything else that I have in my network. And so starting with 862G, we introduced the concept of polling policies. Polling policies are stored in the pollingpolicy.nmis configuration file. The system comes with a pre-built default policy. It can't be overwritten. It can't be replaced. It's the one that is assigned to every device when they are first created, but you can certainly change those, and you can create your own. So let's take a quick look at what those look like, what a polling policy looks like. And what I'm going to do is I'm going to hit the edit node here on my Midgard device. And if we scroll down to the advanced section, you'll see that we have an option here now for polling policy. Now this device is set to default. I'm not going to change the polling policy. It's important to understand that if you change the polling policy of a device, NMIS will actually delete all of the stored, let me say that again, NMIS will delete all of the stored performance data for that device. And the reason for that is NMIS uses as its backend RRD, a round-robin database. And NMIS, when a device is added to NMIS, NMIS creates all of the database files needed to store the base device itself and every interface, every CBQoS metric, all of your BGP table information. All of those RRD databases are created based on a combination of the polling policy, which defines how often data is going to be captured, and your storage requirements. So if your default storage is 7 days of fine-grained performance information, then that database has been set up for a specific amount of time and a specific number of entries over that time period. By changing your polling policy, you'll actually change the structure of that database. And so as a result, if you change the polling policy for a device that already exists in the system, NMIS will wipe out, has to delete all of the old information. Now, what actually happens is NMIS doesn't delete those files; it just renames them and leaves them behind and creates new sets of data. So the old data is still available; it hasn't been deleted from the system, but it's not accessible through the GUI. To get access to that, you actually have to flip back to the old polling policy, and because those old files will then be renamed again, you'll then have access to that old data, but you'll have a gap between when that original polling policy was changed and then when it was reenacted. So you'll have a gap however long that time period was, a day, 2 days, an hour, however often. We ship with 4 default polling policies built in. You have the default one, you have a half hourly, a high speed, low drag, and a very infrequent option. Again, I'm not going to change this device, but you can go to system configuration, polling policy, and get a breakdown. Again, the default polling policy is not editable. You can't change it. It is built in as hard-coded into NMIS. I assume if you want to go in and edit the nmis.pl file, you could dig in there and look for it and change the parameters internally if you wanted to, but then they would end up getting overwritten the next time you did an upgrade. Adding a new polling policy is just as simple as hitting Action Add, or of course you could always edit the actual polling policies.nmis file itself. Webinar sample. So let's say that we're going to do an ICMP ping every 2 minutes. We're going to do an SNMP poll also every 2 minutes. We're going to do a WMI poll every 2 minutes. 2-minute polling policy for webinar, and give it a description. I can add, and now we have that option here. So we have a high speed, low drag of 1 minute across the board, and then we have a webinar sample at 2 minutes. So lots of different options that you can do here. You can assign polling policies per device, or you could, when you look at a bulk edit, you could assign polling policies by whatever parameter you want to in the bulk edit. You could also do a small script that would poll through all of the NMIS devices and perhaps, for example, based on a device's status, state, model, type of device. So you might say, if the device is in the group VIP customers and it has a model of Cisco router and it has a role of core, then assign it to the high speed, low drag policy. So lots of options there for automating that. Over on the right-hand side of this, the PowerPoint here, you'll just see a small example of what that sample fast polling policy looks like. So again, the description, the name of it, the ping time, SNMP time, and WMI collect time. It's a very simple, straightforward hash. Again, assigning it is in the advanced options under polling policies. All right, so custom fields, tables, and metadata tags. So I've heard these things called many different names over the years. Internally to NMIS, our documentation calls them tables. Many of our customers call them custom fields. In my mind, and perhaps only in my mind, I like to refer to them as metadata tags. Because at the end of the day, these are really tags that are assigned to devices to help define information or parameters about the metadata about an individual device. And NMIS ships with dozens of them already pre-built in. So let's take a look at some of the more standard metadata tags. And again, I'm just opening up Midgard here, and I'm going to hit Edit Node. So over on the left-hand side, you'll see things like group. Group is the key table field or key metadata tag, of course, that's used throughout NMIS to group devices together. So you define groups of devices, you define groups, the concept of groups, and then you assign a device to a group. Additional metadata tags, the concept of customer. Again, it's just a metadata tag. Business service, metadata tag. Service status, metadata tag. And it goes on and on. Each of these pieces, the concept of a node context name, remote connection name, notes, the notes field is a metadata tag, the role type, net type, location, all of these are metadata tags. Even the polling policy itself is nothing but a metadata tag defined in a NMIS table and then populated and then assigned to the tables-NMIS or tables-nodes file so that it shows up here in the node edit window. So each of these fields are really nothing but table definitions that are then assigned and collected together and grouped and then assigned to a device. So why would you want to create a custom metadata tag? Well, in many cases, it's for data refinement. You want to be able to group things together in a more granular, refined way. So for example, NMIS ships with the company metadata tag. You might create a second one called department or division. We have a location metadata tag, but you might want to create an additional metadata tag named room or location, floor, service rack, etc. All these metadata tags, they help with searching and filtering on devices. So it gives you the ability to really drill in further and find more information. It allows you to automate scripting much more easily. You can also add custom metadata tags to things like your escalation policies and use additional metadata tags to help drive your escalations inside NMIS. So how do you do it? The first thing you have to do is create a table definition file, and that's simply called table-something.nmis. So if you wanted to do an SLA table, it might be table-sla.nmis. You populate it. You add the definition file to tables.nmis, so that provides a reference to the table you created. You provide authorization to NMIS to talk to the table and gather information to and from it. So it has to have read-write access to the table. so that it can create content for it and read from it. And if you want it to show up in the Edit Nodes widget, reference that in table-nodes.nmis to create that linking between the actual table itself and have it appear inside that Edit Nodes widget. Next up today, thresholding. Thresholding is all about intelligently creating alarm points. Now, one of the questions I often hear from clients, whether they're doing a proof of concept or we're in the middle of an implementation and they're starting to set up and deploy NMIS, is how do I enable thresholds? How do I know where my alarm levels should be? Well, a great benefit for everyone who uses NMIS is the concept that Opmantek's already done most of the work for you. So we're already polling all of the background information about a specific device, regardless of its manufacturer, model number, operating system. We're pulling everything we can based on that device's MIBs and OIDs. We're pulling it in. We're normalizing those events and alarms, those data points, into common names. And then we have series of thresholds that are assigned that start in the individual device's modeling files and then go to a general thresholding file as well. And you can really get very, very granular with those rules to pull in other metadata tags. So for example, you might adjust your thresholding if a device is a core device versus an edge device. So you can adjust different things. You can use those metadata tags to help drive your thresholding policies. Thresholding policies can be rising or falling. So for example, you might want to set off an alarm if a interface usage exceeds 80%, right? But you also might want to set off an alarm, a different alarm, if it drops below 5%. So you can do rising and falling thresholds. Events are normalized across similar OIDs in manufacturers. Again, that way you don't have lots and lots of different names for what amounts to the same type of event. It makes monitoring events much easier in the system, less esoteric. You can edit thresholds. You can do your threshold alert tuning right in the NMIS GUI if you want to. You can also go directly to the common threshold.nmis file and edit it there if you want to. So let's take a look at what some of that looks like. Switching over to NMIS again. So setup, threshold alert tuning. So now the system is read through. It's pulled in all the thresholds. You can see on the left-hand side, it's selected the common threshold model, which stores all of the thresholds that we ship with now. There's only one section in this model. It's the thresholding section. And so every model loads the common threshold section. That way, if there is a commonly named attribute in that model, it can reference this kind of common threshold. You can create a separate threshold section in a specific model if you want to, just for that model or just for yourself. However, it's often easier to manage thresholds by having them all in just one location, one central file. Now, NMIS supports 6 different levels of thresholding, starting with normal, then going to warning, minor, major, critical, and fatal. And again, that can either be rising or falling. In the example you see here for average disk queue length, you'll see, for example, we have warning, minor, major, fatal, and critical. Notice that the display here just goes in alphabetical order. So critical is being listed before fatal, but they actually execute in the other order. And if you scroll down through here, you'll see different types of events: Windows paging events, proactive page file usage. It's pulling the % page usage, default values, different titles that can be shown. So you can actually override the event name and use different titles. You can define what your units are, different types of Windows processing, etc. And I'm just going to scroll down here until we can find an example. There we go. So here's an example where we have a couple of different sets of thresholds, and we're using the role type to differentiate between which sets of thresholds are applied. So in this top one, we're saying role type is something like, so we're using the equal tilde sign, something like core. Role type, something like distribution. And then down here, role type, something like access. And then we have different values laid out here at different levels. So you can see core level devices have much lower alarm levels than do distribution, and distribution has lower alarm levels than do access devices for this average busy 5 minutes proactive CPU alarm. So you can create very, very granular requirements that are here. You could use, again, you can access any of your metadata tags here as a control. You can create complex controls. So you could say role type equals core and group equals my VIP, right? So you can refer to several different control pieces, several different metadata tags. You can even refer to custom metadata tags. So if you wanted to create a metadata tag called SLA and assign it values like platinum, gold, silver, bronze, tin, lead, and spaghetti, you could test for the SLA value and say, oh, for devices with an SLA value of 10, my fatal level is 95%. Let's go back over to the PowerPoint again. So that's really everything there is to thresholding. We ship with hundreds of thresholds, again, across every single manufacturer, all normalized together, so that you don't have to worry about specifics of knowing what things you should monitor or what level you should look for. We just ship with that information. It's already in the system. It's already enabled. We often talk about it, about thresholding and escalations using the concept of a volume dial, right? As you start adding devices to NMIS, the volume on the system is set at 11. And then as you start seeing how the system generates events and alerts, you start dialing back that volume level. You can adjust your thresholds if you need to, although we've got more than 20 years of experience on from both talking to manufacturers and talking to users, talking to engineers across the world on what values make the most sense under certain circumstances and situations. Now, the next piece is escalation policies. And escalating an event is all about telling someone about it. So it's great that events will show up in the NMIS interface. So if we go back over to NMIS. So for example, you'll see that. And we'll see our network events. So this is showing our network events. This is showing our event log. And this is posting every single event that's happening across the system, irregardless of the event priority. So is it a minor, major, warning, fatal, or critical? Is it a normal event? Is it a closing event? So irregardless of that, this is posting every single event here to this point. But generally, we don't talk or teach in our training classes to have users sit and stare at the system. Instead, what we often do is we say, build an escalation policy that monitors your events and then sends out a notification. That might be something like an email or an SMS text message. It might be a net send. It might be writing information about that out to a JSON file. It might be pushing it out to a file on another server that gets picked up and read by a BI system. It might be pushing an email into a help desk system. It might be connecting to an API and executing some set of commands through an API to a third-party system like a help desk and generating a ticket or notifying someone that something's happening. So how do you do it? First thing you have to do is you have to create contacts. So who will you send the notification to? You might even have a contact that's nothing more than your help desk, right? You then create escalation policies. So these are rules that have to be met in order to generate the escalation. You can then test the notification, make sure that it works, and then you adjust the configuration if needed. So this all starts with the concept of escalation periods. So an escalation period is really nothing more than a timeline, right? So think back to third grade, you've got a dot on the board, and then there's a line heading to the right off it with an arrow. The dot, that starting point, that left-hand starting point on that line is time 0, or in this case, escalate 0. So we have a what's called an internal escalation table. It's part of your config.nmis. It defines the points on that timeline when things can occur. We ship with the defaults that you see here on the screen. These are all in seconds, so 0 seconds, 300 seconds, 900 seconds, 1800, 2400, all the way up to 86,400 seconds. So that's 24 hours. So 24 hours after this event occurs, what do you want to do? After escalate 10, the system cycles back around and starts over at escalate 0 again. So you define the periods along that timeline when you will do something, right? And you might change, who you call, when you call them, how you call them, etc. So you define your escalations, you define your contacts. So this is the example for contact 1. You can see that it has a defined duty time of 6 a.m. to 8 p.m., so 06 to 20. So it uses military time, the 24-hour clock. Monday, Tuesday, Wednesday, Thursday, Friday. So this person works 6 a.m. to 8 p.m. Monday through Friday. And this person will receive alarm levels of fatal, critical, major, minor, warning, and normal. You have the email for the individual, their location, their mobile number, their pager number, their phone number, and their time zone. The next thing you do is you combine these two things together, these concepts, these escalation time periods with the actual escalation policies. And you can create as many policies as you want. You can restrict the policies to specific groups or all groups, to specific roles or all specific types of devices or all devices, specific events or all events. You can even break it down to a specific device, which is called an event node, or a specific interface, which would be an event element. And then the levels that are here are related to the escalation levels that were defined earlier. So the times along that timeline, what do you want to be able to do? So for example, following this example, each of these pieces at the top that are default means any. So for an event that is on a device in any group with any role of any type of any event, at level 0, which is escalate 0, which is time 0, create a net send to workstations 1 and workstations 2, and then do an email to contact 1. At level 1, which is 300 seconds in, do a pager to syscontact, and then do an email to contact 2. At level 3, do an email to contact 3 and an email to contact 4. So several different options that are here. You can actually stack these up. NMIS ships with some built-in notification methods, syslog, JSON, email, ccopy, pager, and netsend. These can be expanded on. These are nothing but little Perl files. So you can actually create your own type of notification method. Many people will create an SMS notification method. They might create an API, help desk API notification method. So you can create your own notification methods and add them into the system. That's actually covered in another webinar that we did called Event Escalations. So coming down to our last couple sections for today, how do I get devices into NMIS? This is one of those things where even clients with smaller networks, 50, 100, 200 devices, working through NMIS's interface, picking and choosing devices one at a time. So for example, again, I'm just going to close these two pieces and saying setup. And coming down to add, edit nodes and devices, I can add an individual device here, select all my settings for it, and then hit add an update, and NMIS will create all of the RRD database files needed for that device. It'll also reach out to that device. It'll do an SNMP walk. It'll try to determine what kind of device it is. It'll do a collect, an NMIS collect on that device as well, and try to begin communications with it and start plotting some points on graphs. So you can do this one at a time if you want. Generally speaking, if you're doing just a handful of devices, it can be quite fast to go through the add, edit nodes and devices panel. However, if you're going to be populating anything more than a handful of devices, what we really recommend is to use our bulk import. So there's a couple of different ways of doing bulk imports. The simplest, which has been around for quite some time, there is a nice little Perl script called import nodes.pl that will import the 5 mandatory fields from a provided CSV, and we ship with a sample CSV called import node sample. So you can grab the import node sample, take a look at it, see what the format is, and then use import nodes.pl to ingest that CSV and add those devices to NMIS. Now the nice thing is that import nodes.pl, just like all of NMIS's code, is not compiled. It's open source. So you can actually open and edit the import nodes.pl file to pull in more than just the default 5 minimum required fields. So if you want to set, say, the customer, you want to add device notes, you want to perhaps change the polling policy for a device, you can actually put all of that type of information. You can update import nodes.pl to set those fields, and then run it and import your nodes into NMIS. So that's one quick down and dirty way of doing it. There is also a kind of a corollary to import nodes. That's export nodes.pl. Export nodes.pl takes a single parameter or argument, and that's the name of the file that to export the nodes into. Otherwise, it will simply export your devices into a CSV file with appropriate headings that you can then use for whatever you need. Many clients who are looking to do a large-scale edit of their devices, they'll actually export their nodes using export nodes.pl. Excuse me. They'll export their existing devices using export nodes.pl. Open that in some kind of a CSV editor, whether it's Excel or whatever they need. They'll edit the settings there and then re-import changed devices. And so you can actually overwrite the settings of your existing devices that way. Again, you'd need to update import nodes.pl to handle the additional fields. A new addition just came out a couple releases ago, which is a huge benefit for people who are looking to automate NMIS at a large scale, is the concept of using the node admin.pl script. Unlike import nodes, which is very simple, it's only about 20 or 30 lines long, admin nodes is a very, very large, very complex script. It does an awful lot of stuff. I've just provided a few examples here, but you can create new devices, you can export devices, you can update existing devices, and you can even delete devices, meaning you can delete all of their stored performance data as well. So node admin.pl, very, very powerful tool for you. It does allow you to kind of cycle through. So for example, you can do node admin.pl act equals list. It'll give you a list of every single device, and then you could work through that list and say, I want to export each of these devices one at a time out into a JSON file. And then you could bulk go through those using a script and edit things you need, and then push those new JSON files back in again. But the node admin.pl gives you a much more refined, deeper access to a node's settings and its parameters than the import nodes and export nodes processes previously mentioned do. And as we wind down this presentation, I've got a couple bonus extras for everyone. So if you're looking for ways to troubleshoot device collection, there are several reports under reports/current, and that's the collect update time. You can sort that by the column header. So if you're having issues getting data into devices, you want to check your collect update time on those devices. And you also want to check the response time. If the device is taking too long to respond, NMIS may have moved on. If the collect time exceeds its polling policy, so if you have a 5-minute polling policy, but it's taking 8 minutes to do a collection, then it's never going to finish its collection before the next collection starts. So some of the things you might want to look for if you're troubleshooting, you want to look and see if there are any open events, like maybe SNMP down. Is the device responding to ping? Is it responding to SNMP or WMI polling? What model is assigned to the device? And of course, if NMIS as a whole is having challenges, you absolutely want to look at the NMIS self-test. And of course, you want to look at the NMIS runtime graph. So let's just take a quick look at what the NMIS runtime graph looks like. So system host diagnostics, I can access the self-test. So I'll get this here. And if there's a major problem with the self-test will actually post and replace the metrics window. So if you have the metrics window up, the NMIS self-test, if any of these items fail, will actually populate that metrics window. And of course, we also have the runtime graph. So the runtime graph will tell you how many seconds it's taking to poll all the devices in the system, what its total runtime is, how many processes are assigned, how many max parallel processes there are. So you may want to look at this and consider maybe you want to add more threads. You might want to add more parallel processes to the system. You might need to add a little more CPU or memory to be able to take care of that. But by starting and looking at these types of performance information, it'll give you a good idea of how well the server is processing and handling the load that's on it. I want to thank everyone for your time today. I appreciate it greatly. Again, my name is Mark Henry. I'm a senior engineer here with Opmantek's North American office. If you have any questions at all about these subjects we've covered today, feel free to email me at markh@opmantek.com. If you have any questions about obtaining commercial support or maintenance, please reach out to Tom Weary at usa@opmantek.com. Tom will be happy to answer any questions you have about pricing or availability for support and maintenance contracts for NMIS. Thank you again, and I look forward to talking to you soon.